So to motorize this thing, I looked for a gear reduction, and I found for $5 at a scrap dealer's I bought an exercise machine that had this motor and this 20-to-1 gear reduction on it. And then I felt like that was running too fast, so I ran rollers here and sprockets and geared it down another approximately 2-to-1. So it's geared down approximately 1 revolution here to a 36 or 40 on the motor. So it probably runs at, like, well, whatever. Divide 1700 by 36, 50 RPMs or something like that. Doesn't really matter what it runs at. So 2 pillow block bearings here that support a shaft, and what I did was I took the auger of the Mercado and I cut a flat in it. And then this shaft is oversized. It's got a hole drilled in the middle that with a slip fit for this, and then there's a set screw on each side that grips here. That's what drives it, is these 2 set screws just pushing. All this is a way of making a flat slot in there. So this slides into there, and then the what I did is I cut down the frame and just basically compacted the whole thing, and then I drilled 2 holes here, and the oil press is bolted on there, with this lining up with the center of this is lining up with the center of this shaft. Then the big problem with these is the thrust bearing. Of course, anybody who has these knows they're a big problem. I switched to bronze thrust bearings, which helped a lot. But I finally broke down, and a ball bearing type thrust bearing is not available for this thing anywhere in the world, so I made one. Hardened. All it is tool steel. What I did is I found a 1-inch diameter shaft in my shop. Sliced off a little piece of it, heated it red hot, quenched it in oil, and found out it was hard enough so you couldn't file it good enough. That's the steel I'm going to use. So for all you machinists out there, I took a 1-inch diameter piece of this shaft, mounted in a V-block in a rotary table, and then I cut, a piece of shafting a couple inches long or whatever, so it's running through. And then I cut a 3/16 with a 3/16 carbide cutter. I cut a radius in here. Then I took it out of the V-block, sliced it off with a bandsaw, and faced the back off. That's how I made that. I made 2 of those, 2 races, quenched them in, heated them cherry red, quenched them in used motor oil, so they're real hard, and that's the 2 races. Then for the bearing retainer, these are what these are is 3/32 radius, 3/16 ball end mill or ball cutter basically, and 5/32. The bearings have to be slightly smaller diameter than this radius so that it actually rides on one point. Now this was made in the same setup. I put the shaft back in the V-block, and I went around and I drilled a series of equally spaced holes exactly in the same places where this radius is, and I made them just a slight slip fit for a 5/32 ball bearing. I got these bearings out of, I just took an old sealed bearing and cut it open with an angle grinder with a cutoff wheel and got these bearings out of it. And these holes are just maybe 2/1000 or 1/1000 bigger so that the bearings would slip in, but you got to be able to make it so they don't fall out. And the way I did that was after I got these holes put in, I laid this on an anvil, and I took a 1/4-inch diameter ball bearing and held it with a needle nose vice grips and laid it right on top of each one and tapped it with a hammer. Tap, 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 tap. And I swedged the metal on both sides. Tap, tap, tap. And that made those holes a little bit undersized on the top and the bottom. And then I was able to press these in. And now they're held in place, but they run smooth. So basically a way to make a bearing retainer. So now we got a friction-free thrust bearing, which is what these really need. When I originally made this is only an 1/8 horsepower rating gear reduction, And if we made 1 quart of oil in it, this thing overheated to such a degree that it would sizzle when you put your finger on it. It got so hot, it just wasn't rated for this. So then that was with the bronze thrust bearings. After I made this ball bearing thrust bearing, then I could make a full gallon without this overheating. In other words, most of the power that's required for this thing is lost in the thrust bearing. It's really inefficient, and sometime I should hook this up and hand crank it. It would have to pull so easy. Anyway, so now this thrust bearing slips over the shaft, and you don't have to modify the shaft. There's enough room in here for a 1/2 inch thrust bearing. And then this slides in place, goes into this, and then my homemade nozzle goes over that. And the nozzle, you know, I gave you that drawing of how the nozzle would. The nozzle originally was made with stacked plates because I wasn't sure what size I needed. I started, you know, I stacked up 2 plates. There's a nice smooth taper inside. I put 4 holes in, bolted it together, and then machined the taper in so that it was all nice and neat. And then I tried it, and immediately I could tell that this was too small because it pulled too hard. So I took this one off. Actually, I think I originally had 3 plates, but I don't remember anymore. And I kept trying them until I found one that works. And so the drawing I gave you was actually what this is. But you don't need this extra plate on top. The threads that I showed you, or the threads that are in the drawing, what I did was I cut straight threads because what this is pipe threads. They're tapered, and I have no way of cutting tapered threads in my lathe. And if you use a pipe tap, it won't go deep enough. The objective is for this surface here to bottom out on the shoulder. That's what keeps the sunflower meal from building up in an undercut. You want to have it all real tight. So I just cut straight threads that slipped onto this.
Cut threads on this here?
I cut threads on here just with straight threads, but the same number of threads per inch. And then I just kept cutting them out and trying it until
But these are new threads you cut on here?
No, these are pipe threads. Okay. These are what it came with. So it's actually a tapered pipe thread going into straight threads, but it works.
Oh, okay.
So another way you could do it is if you had a pipe tap, you could cut the end of the pipe tap. You could thread this in and so far, and then cut the end of the pipe tap off and keep going in until you get it to where it bottoms out against that shoulder, just like that. So now it's ready to go. The other thing I did was I made a cute little stainless steel. This is just made out of a piece of stainless steel tubing I had laying in the shop that I welded together. It's just a little spout so that and then I made a little spring arrangement to, and then you can put a quart jar underneath here. The oil runs down here and into a jar. That makes it a little easier. The other thing I did is I took a piece of PVC and machined it so I could put a gallon jug on here, so you can hold more sunflower seeds. And other than that, that's it. Anyway, it works. Now what we got to do is we got to start heating it up, and in the meantime we're warming up. We got the oven set at 200 degrees. If you preheat the sunflower seeds to a couple hundred degrees or 150 degrees, it helps quite a bit. This is at 250 or something, so I guess that's actually up to 350. We'll shut that off. That's plenty hot. They've been in there about 10 minutes, so they're warm enough. I'll just shut the oven off now. Now we got to light the, let's see, where's the, yeah.